Hello everyone. My name is Yoav Kantor, and I work in IBM Research in Israel. In the past 6 years, I've been working on a project called Project Debater, and today we will have a hands-on session where you will use our services to analyze and find insights in open-ended questions in a survey. 2 weeks ago, in the previous session, my colleague presented Project Debater and the Early Access Program, but for the sake of the participant that didn't participate in the previous session, we will have a short recap for about 10 minutes, and then we will go on and do the tutorial. The hands-on tutorials will take about 1 hour, depends on how many questions we have and so on. So Project Debater is a grand challenge. It's a big project we've been working on for several years, and it's the first computer to successfully debate champion debaters. When the project finished, after the big live event, we took the core abilities from the project, from Project Debater, and we made them accessible in a set of microservices. These microservices are called the Early Access Program. They are free for use for non-commercial, non-commercial use, and you can go to this site. I also put the link in the chat. You can go to the site, log in as a guest, and read about the services. We will take a look at the site together soon. But if you want to also run the services, you will need to send us an email and get credentials for the site. So again, the mail is written here. I also put it in the Zoom chat. Let's take a look at the Early Access Program site together. In the first tab, you can read about Project Debater, see different videos from the live event and others. In the second tab, you can see the 12 services that we currently have available. You can look at code examples in the third tab, download the SDK and run the services from your Python code or Java code, see open source projects we've made public, data sets that we've published, and so on. When you log in as a guest, you will not be able to get an API key from the site. After you send us an email, we'll be happy to grant you with credentials, and you get your own permanent API key from the site. For this tutorial, as we've said before, maybe hope you've heard, you can go to this spreadsheet. The link is also in the chat, and randomly select one API key, mark it as taken, and take an API key for this tutorial. So if you look at the services in the Early Access Program, each service has a short description and also a longer description. And most of the services can be tested directly from the browser. We will not go over all the services. I encourage you to go to the site, read about the services, play with the results, change the text and see how the services work and respond. And we will only take a look at 4 services, the same 4 services that we will also use in the tutorial. We will take a look at the argument quality, the term wikifier, the term relator, and the key point analysis. The argument quality is a service that receives a sentence and a topic and returns a high score if the sentence is well structured and clear, but also related to the topic. We will use this service to select high quality sentences and filter out lower quality sentences. The higher quality sentences will also be more informative. The term wikifier is a service that receives a sentence and finds the wiki concepts inside the sentence. So, for example, if we have the sentence, cars should only assist drivers since self-driving cars are too dangerous, the service finds the following wiki concepts. Wiki concepts are like the page title in a wiki page. So it finds cars, drivers, and self-driving cars. The term relator receives 2 concepts and gives a high score if the concepts are related. So for example, Rottweiler and a dog receive a relatively high score, but for example, Hebrew. But a shirt and a dog returns a low score. You can read about the key point analysis service here, also see different publications. but I will present the service from my presentation. When you have a large collection of opinions, that can be user reviews, surveys, customer feedback, online discussions, also from social media, you can summarize them and find and extract actionable insights from the data using the key point analysis. Key point analysis first finds a short list of concise sentences. These are called key points, and it then matches all the sentences to these key points. The salience of each key point is determined by the number of matching sentences. Let's take a look at an example. Here we summarized a data set of consumer complaints. The data set had many thousands of sentences of comments, and you can find here the top 6 key points that were automatically extracted from the data. If we take a look at the first key point, incorrectly reported payments, dates, and amounts on my credit report, this complaint had almost 3,000 matching comments, 14% of the data. And with 6 key points, we managed to cover 51% of the data, and obviously creating more key points can increase the coverage. This summarization method has both a readable part, the key points themselves, you can easily understand what people complain about, but it also has a quantitative part, the number of matching key points, which is also the salience of the key point. So why should we use key point analysis? Because it's human readable, but it also has the quantitative part. If we want to better understand the key point, we can also take a look at the sentences that match the key point and find different nuances in the data. It also correlates with structured data, meaning if the data comes with additional information, such as different years or different areas or different users that submitted the data, you can create different subsets of the data, run key point analysis on each subset, and since it has the quantitative aspect, you can compare between them and find insights from this comparison. We will see an example for this in the tutorial ahead. Another way to use the service is called human in the loop, where you first automatically extract key points. You then refine them, maybe rewrite ones that is not perfect, remove duplicates if there are such, or maybe add ones that you think are missing. And then after quickly revising them, running the system again, this time with the given set of key points, and obviously getting better results. It also doesn't require a domain-specific training. It works well across different domains. So let's get started with the tutorial. I apologize for the problems we have with the API key or the confusion. We have the link to grab the API key from the spreadsheet. I hope that you've managed to do so. Now, I also put the link to the Drive folder. I hope, again, you've managed to open it. The folder has 4 notebooks. One is a simple notebook for in a low world that enables you to check that the environment works. But the other 3 are for this tutorial. The first one is the official tutorial where, please share the link again. Okay, I see people ask for the link again. I will share it again.
Let me share the link. You can focus on.
Okay. So the Austin demo is the official demo where you will need to fill in some small gaps in the code and make it work. The second one is already completed with the answers. And the third one, in case you have problems running it for some reason, and since there are many participants, it will be hard for me to assist. The third one already has the answers in it. So you can open it and select Google Collaboratory. If you don't have it, maybe you can connect more apps and find it. Another option is to download it and upload it directly to Google Colab. And once you open it, you'll find the notebook inside Colab. So maybe let's wait 1 second for people to be able to do so. Okay, so this is the Austin demo. Let's please open the Austin demo notebook. And in this tutorial, you will analyze survey answers in a survey that was conducted in the city of Austin, where the citizens of Austin were asked if there was one thing you could share with the mayor regarding the city of Austin, what would it be? So analyzing open-ended questions is obviously very challenging. And for that end, you will use several services. And the main one is the key point analysis. And we will show you exactly how to do so and even improve the results along the way. So you will need to put your API key here in section number 0. Section number 0 installs the SDK inside the Colab environment. And after that, there are 4 sections. I will let you do a section, wait for about 10 minutes for everyone to finish, and then we will go over the section together and continue to the next one. So having 4 sections should take about 40, 50 minutes. If you have questions, I'll be happy to answer. So yeah, please go ahead. The tutorial should be self-explanatory. Go ahead, read the explanations, do section number 1, and in about 10 minutes, we will go over it together. And feel free to ask me questions during this time. Thank you.
Also, if I see some folks say the API key not working, maybe that key is already being used by somebody else. So feel free to grab another one. And for those you, as soon as you grab the key, mark it as in use. So for the other folks can grab the other one. Yeah, if that doesn't work, try another one. Maybe you can scroll down to the bottom to make sure nobody uses that one. And in the notebook, yeah, you only need to replace the first one. Put your API key here. In the notebook, I think there are 2. There are 2. Put your API key here. I think the second one is only kind of like to
it's a check, yeah. Somebody asked what's a CURL? That's a curl. That's a command in Linux where you can run a REST request from the command line. So you can also access the services by sending command lines from using CURL.
And also for the questions, you make sure to send your questions to everyone. So everyone else can see the messages, the questions, either the speaker or myself, we can answer your questions. For those who just joined right now, you need to open up the Colab instruction document, which have all of the steps to how to get the API keys and the steps. Let me resend the links to the chat so you can click it to access.
Someone asked, what's the type of file? I'm not really sure. Maybe we can check it. I think we can do something like I will not have the, I need to set up the environment first. No, API result is not defined. So in exercise number 1, you need to fill in the gaps. You need to replace the please implement with the code. I tried to specify the exact thing that should be implemented. There are 4 steps when implementing this section. And the person here in the chat says that KPA result is not defined. Therefore, I think he didn't get the result and put it in this parameter. We will wait a bit for everyone to finish and then go over the section together, and maybe it will be clearer. You can always cheat and take a look at this notebook that already has the answers and see what's missing.
There also a question, is it possible to use Jupyter Notebook AWS instead of Collabs? I'm not sure you answer the questions, but I think it should be fine. You just need to set up some environment if they're using the Jupyter Notebook.
Yeah, I didn't do it myself. I managed to run it also in Watson Studio, but sharing it from Watson Studio was didn't hold all requirements. So I decided to use Colab, but all in all, it's a standard Jupyter Notebook should work fine from in different ways. So maybe let's wait, I don't know, a few more minutes, make sure that everyone had the time to read and examine the result themselves. And then we will go over the first section together. Someone asked, how was the term relator trained? Is it a Euclidean distance between word vectors or something different? I'm not too familiar with the service specifically. First of all, in the site, you can read the publication that describes exactly the data set that it was trained on and the exact steps. If I'm not mistaken, it was they used paired and they trained it on pairs of terms. But again, I don't want to say the wrong answer, so maybe it's best to read about the service in the site. And if you find that your answer that is not answered from the site, contact me and I'll talk to the people that implemented it. Why Colab? Someone asked why Colab and not other popular Jupyter. I wanted to, the simplest way to share a notebook and let you run it online. There are alternatives. This one worked and was easy to share, so I chose this one. I'm sure the notebook is a standard notebook. You can run it however you like. Someone asked about the domain. I think that you finished section number 1. If you need additional more, if you need more time, please write me in the chat. You can write to me directly or to everyone if you like. And we will wait some more. If no one tells me he needs more time, we will go over the first section. All right, great. So hope you read the introduction. Also, I've been talking about it a bit before. First section just sets up the environment. Someone wrote me something directly. I will answer it soon. So in the first section, we randomly select 1,000 sentences from the data from 2016 data. We read the CSV. We first read the CSV and check the first 5 lines, see that each sentence has a unique ID, text, a district, and a year. We will then read the sentences to this parameter and filter and keep only the 2016 sentences. We will then randomly select 1,000 sentences and use them in the following run. So before running the key point analysis, we will need to do some initialization. We will create an object called debater API. This object enables us to retrieve the different clients we need to access our services. One of them is the key point client. And we also define a domain. Key point analysis runs over a domain. A domain is the place where you upload your data into. Usually a user can have many domains, usually one domain per data set. So here we will run over one data set and we will use one domain. The domain has a name. That's the name is Austin demo. And when we run key point analysis, there are more or less 4 steps. Okay, so we take the sentences, we first split them to texts and IDs, and then we first upload the sentences to the domain. Since we already split them into sentences, we tell the system not to split it. Usually it splits them to sentences, but in this case, we don't need it. So we disable this feature. When we upload the sentences, the system processes them, which doesn't take long, but takes a little bit of time, and we need to wait for them to be processed. When they are ready, all the sentences in the domain are processed. We can start key point analysis operation on them. We tell it which domain we want to run, which IDs we want to analyze, and we also pass something called run params. The run params is a dictionary where we can add different parameters that customize and change the result. We will see different parameters in this tutorial as well. Since running key point analysis can take some time, the bigger the data is, the longer it takes. We immediately receive a future, and using this future, we can get the results. In this case, we wait for the results, we get them back and return them. Another thing we return is called a job ID. It is stored inside the future, and each job has its own unique ID. We will use this job ID in the following section. By the way, if the text is too small or something like that, please write in the chat and maybe I'll increase anyhow. So after defining the method, we can run it over the 1,000 randomly selected sentences. And we also pass this parameter, telling the system to give us only the top 20 key points. We get the result and we print it to the screen. Let's take a quick look at the results together. We've reached a coverage of 28%, meaning about 28% of the sentences were matched to a key point. That's still relatively low, and we will improve it in the following sections. Let's take a look at the key points themselves. This is a key point. This is the number of sentences that match the key point, and we print the top 2 sentences that match this key point. So the first key point is we need better mass transit. Let's keep the second key point for now. Affordable housing is very important. Homeowner taxes are a problem. Water costs too much, and so on. We can easily understand what people complain about and see again the number of sentences that match this specific key point. The second key point is a little problematic because it talks about 3 different topics. And we cannot know if the 34 matching sentences match, which topic do they match to, right? So we prefer key points that talk about only 1 topic and are more concise. We will again improve also the key points in the following section. So again, hope that that everything is clear. If not, write your question in the chat. If you have a unique problem with the way you implemented it, you can open the second notebook with the answers and find what's missing. Please go ahead and do the second section. In the second section, you will improve the results by selecting the 1,000 top quality sentences. Improving the quality of the sentences will also improve the results. So the person that asked how was this domain created, when we upload comments into a domain, if the domain does not exist, the system creates a new domain with this name. So that way you can create a domain. And obviously, as I said before, you can create several domains, usually 1 domain for each data set. Someone asked, is it possible to have a high argument quality for a factual incorrect statement? So the answer is yes. We don't check if the argument is correct or not. It's not a fake news detection or something like that. As I said before, it checks that the sentence is well structured and clear and is related to the topic. So non-correct or incorrect sentences can get a high score as well. And again, for the data set that the model was trained above, or to read more about the service, everything is in the early access program site. If someone still has a problem with the API key, something's not working, you can let me know in the chat. Otherwise, I'll assume everything is fine. Someone asked about what's the meaning of sentences well structured. I agree that it's not well defined. Again, for more details on exactly how the model was trained, you can read in the site. But I don't think it's like a grammatical check of the sentence. If I remember correctly, it was trained about over pairs of sentences which were compared and the labelers needed to label which sentence is of higher quality, and that way they trained the BERT model. But again, take my answers on that with a grain of salt. The correct answers and the full answers are in the site. The key point analysis service was trained on a big data set called RKP. The data set is available from the site. And if you have questions about the key point analysis service, I'll be happy to answer. Someone asks for the links. Let me put them again. What happens if you run key point analysis, the key point client, without waiting for the comments to be processed? That's a good question. Let's wait till I get the right answer. I don't remember if it checks before and fails or not. Yeah, I don't remember if it checks if the sentences are ready. I actually think it doesn't. So it will probably run on the sentences that have already been processed. Please don't do so. Maybe we can add that check to the system as well. Okay. Now, section number 2 we run over the top quality sentences instead of randomly selecting sentences. Another thing we do is customize the results in section 2.3, somewhere around here. We customize the key points results. So if someone wrote that the key point analysis result is not defined, it should be defined if let's take a look. Well, maybe I'll go over the answer for exercise 1 again. We upload the comments. We wait for them to be processed. We start the job and immediately get a future. And we then use this future to wait for the results to be finished and save the results in a parameter called KPI result. Therefore, when we return the result, KPI result should be defined. I guess that if it's not defined, then there is a problem in this line. If you need additional time for section number 2, please let me know, either directly or write to everyone in the chat. Yes. Yes. So again, for the one that maybe joined late, there are 3 notebooks. This one has some code missing where you need to fit it in. The second one already has the answers in it. And the third one, in case you're not able to run it for any reason, you can open the third one that already has the result as well. So you should open the first one, but if you have problems, something doesn't work, you can always open the second one. So you're not related to sound good. Taking so long. All right. About the argument quality, it's not only sentences that sound good. First of all, let's maybe go over the second section together, and maybe we'll see what the argument quality service does. And why does it take so long? First of all, someone asked, why does it take so long? First of all, there are now, I think, 40, 50 participants that run everything in parallel. So that's a relatively higher than usual load on the system. But yeah, it shouldn't take too long. Again, if someone needs more time for the second section, please let me know. So in the second section, we select the 1000 top quality sentences from 2016. So this method receives the sentences and the topic and uses the argument quality service to receive a score for each sentence, obviously, and it sorts them descendingly and selects the top 1000 sentences. Before that, it prints the top 10 quality sentences versus the lower 10 quality sentences. We can see that the service nicely splits between higher quality sentences and lower ones. Again, you can go to the site and play with the service and examine it a little more, also from code here. Someone asked if it just selects sentences that sound good. No, it doesn't. It tries to find the sentences that have higher quality according to the labels that were collected when the model was trained, obviously. So again, you can further read about the service, about the data that was collected and how the model was trained in the website. After taking the top quality sentences from 2016, we run again the same method and get the result and print it to the screen. The coverage before was 28%. Using higher quality sentences increased it to 41%. Let's take a look at the key points themselves. Traffic congestion needs major improvement. We need affordable housing. Integrated transportation is critical. Utility rates and property taxes are outrageous. So the key points are clear, concise. We can understand what people complain about. We have the number of matching sentences, obviously, for each key point. And I think we get relatively nice results. And here we demonstrate 2 features that are available in the service. The first one is called hierarchical key points, where you can ask the system to group together in 2 levels the key points. So if we add to the run params these additional parameters, the run param is a dictionary where we can add additional parameters to customize the service. So we tell it to perform key point hierarchy, and we also set a threshold. We can play with it. And again, run key point analysis with these customizations. We print them to screen. And this time, after creating the key points, it checks which key points has a similarity score above the 0.3 and groups them together. So this is the first key point. Traffic congestion needs major improvement, and it still has but it still has 88 matches. But below it, since it has additional key points below it, the subtree has 107 sentences. The second key point that matches it is there is constant traffic and noise pollution, and we can see that it's really related to the traffic problem. And the third one, or the second one below it, is roads are poorly maintained. So we see that it grouped similar key points one to another. We need affordable housing. Housing prices are out of control. So this feature again groups them together, makes the results even better. And in the next section, we play with the matching threshold. The matching threshold determines whether a sentence should be matched to the key point. When we reduce the threshold, more sentences will be matched to the key points. This will obviously increase the coverage. The risk is that it will reduce the precision. As usual, we have the precision to coverage trade-off. And so let's take a look at the results. We run again on this set of sentences, but this time we reduce the mapping threshold to 0.95. The default is 0.99, and we slightly reduce it. We print the results, and we see that the coverage was increased from 41% to about 50%. The key points are, I think, similar, but more sentences are matched to the key points. Now, as I said before, the risk is that the precision will drop. For that, we take the first key point and print the bottom 5 sentences that are matched to this key point. The matching score is still above 0.95%, but these are the last ones that match it. And if we take a look at the first sentence, the biggest problem Austin has is a lack of viable north-south arteries. This sentence does match the key point. We see that it has a strong semantic similarity, even though the syntactic similarity is very weak. There aren't any similar words between them, between the sentences. So if we take a look at the 5 lowest sentences, we see that the precision is still relatively high. Except for saving the result when we run the key point analysis, this time we also save the job ID, and we will use it in the next section. Please go ahead and do section number 3, where you will analyze the data from 2017, but compare it to the results from 2016. I will now check the chat and see if there are additional questions. Someone asked about the key points. Were they defined by the users or found by the program itself? The key points are automatically extracted. They are found from inside the data. The system knows how to select the best key points that are short, concise, and have the highest coverage of the data. So yeah, they are automatically extracted. And as I said before, we can also improve it, run an automatically extraction phase, get the automatically extracted key points, refine them a bit, rephrase them, delete duplicates, add things that we think are missing, and then run again the system, but this time with the given set of key points, the revised key points. That way we can also improve the results. Okay. After automatically extracting the key points, it takes all the sentences in the data as is and matches them to the key points. The coverage says how many were actually matched to the key points, but the sentences are the sentences from the data. Okay, someone asked if the key points are generated by the algorithm or are they selected from the sentences themselves? So the sentences are selected from the data itself. That's an extractive summarization method. Government, someone asks if government use a project debater considered commercial or non-commercial. Well, I'm not sure. Please send us an email and we'll talk and figure it out. I'm less aware of the legal aspects of using a project debater. Okay, someone asks, was the key point generator trained on some specific type of data? Will it be able to generate semantically sensible key points on some unique set of sentences? First of all, it was trained on on a data set called RKP. If you go to our site, go to the data sets and you will find the data set itself. Let's see where I return to. 1 second. So you can see, you can even use the data set that the model was trained on. It is usable for different domains in the opinions domain, survey answers, user reviews, things like that. Working on data you've mentioned, the figure captions or things like that. If the language is too different, it might need specific tuning. What kind of algorithm is sitting in the back? First of all, full description is in the site. Maybe I'll have time to try and give a quick overview. Let's see. Okay, using the algorithm or purchasing it. First of all, the algorithm was patented. So again, legal aspects of using the algorithm or things like that should be discussed by sending us an email. I'm less familiar with this side of things, with this aspect. Does anyone need additional time for section number 3? If so, you can write to me directly in the chat. Someone needs a link to the site. The site is the early access program site. We've looked at it together. I've put the link in the chat before as well. Again, under the services, under each service, you can find the papers that were published, the data sets that were published. And if you have additional questions, always feel free to send us an email. So no one told me they need additional time. So let's go over section 3 together. Again, in section number 3, we analyze the data from 2017, but this time compare it to the results from 2016. So we first select the sentences from 2017. We use the same method and get the top quality sentences from 2017. But this time, we don't want to run automatic key point extraction on 2017 because we will get a little different key points, and comparing different key points will be hard to do. Therefore, this time we will receive the job ID from the previous job and use the key points from the result, from the previous job's result. So the new run KPA method will receive the job ID from the previous job, we'll pass it to the start key point analysis job, and when we pass a job ID, it will find the result, take the key points from that result and match the sentences from 2017 to these key points. That way we will have an analysis, but with the same key points as the previous job. So we use the 2017 sentences, but pass it the 2016 job ID, use the same parameters, and get the result, print them to the screen. We get the exact same key points, but this time with 2017 sentences. The coverage is still relatively high, about 50%. And now that we have two results with the same key points, we can easily compare between them. We can print the key points, the number of matching sentences in each subset in 2016 and 2017, and see what changed, what improved, and what didn't. Obviously, we are running here on a small data sets, on a small amount of sentences, so the results are have relatively low statistical significance. But looking at the top key points, we still can get some sense of and compare between the years in this case. Now, taking the data and splitting it to different subsets is very powerful. We can split them to different years, we can split them to different districts and see problems that arise in different districts, maybe split between different types of users, of citizens in this case, maybe according to the socioeconomic status or something like that. And yeah, and compare between different subsets of the data. That way we can extract additional insight from the data. So section number 4, the last section. In this section, we will deep dive and better understand the problem, the traffic problem. As we've seen, the traffic problem is the first key point, is the biggest problem in the city of Austin. We will this time use the term wikifier and the term relator to select the sentences that address specifically the traffic problem and run key point analysis on them, again, to better understand the traffic problem in Austin. So please take about, again, 5 to 10 minutes, and then we will go over the results together. What is the meaning of the coverage? The coverage is the percent of sentences that were matched to the key points. So we have a threshold for the score, the mapping threshold. The default is 0.99. We've also reduced it to 0.95. And sentences that have matching score to the key points above this threshold will be matched to the key point with the highest score. If a sentence has no key point with a score above 0.95, it will not be matched to any key point. In the result, we add a non-key point where all the sentences that don't match any key point are matched to this non-key point. So the coverage is the percent of sentences that are matched to a key point. Someone asked for me to explain in more details the algorithm of the backend. I'll be happy to do so. It still will be, I'm not sure it will cover all the details, but in general, we receive all the sentences, we use the argument quality, and then take both the shorter and the higher quality sentences, and these sentences are not our final key points yet. They are key points candidates. They are candidates to be key points. We then match all the sentences to these key points candidates, and then according to the order, by first looking at the candidates with the highest number of matches, I thought it will be easier to describe. Well, we consider the order, the number of matching sentences, but also remove duplicates between them. And after comparing them, we only select the top key points that don't have duplicates, right? So it's like a two-phase algorithm. It was harder to describe than I imagined. Let me think if I can. Well, obviously, there's the paper that describes the algorithm in fully, which you can find in the site. So again, in general, we take the sentences, create a set of key point candidates, match all the sentences to these candidates, remove duplicates, and the top candidates that survive the duplicate removal are the final key points in the algorithm. More or less something like that. Someone asked if finding key points is a type of clustering. That's a good question. It's a bit similar to clustering, right? But you don't, when you cluster sentences, you group them together, usually using some sort of a similarity score between pairs of sentences. But after you cluster them into a cluster, it's hard to decide which is the representative, right? Why were they clustered together? If you take the one in the center, it will not always catch the similarity inside the cluster. So you can think of it as a type of clustering, but it's a directed clustering. It's the similarity is directed from the sentences to the key points. So in advance, since we start from the key points, we know like what's the center of the cluster, in a sense. So if the match score, the directed match score between the sentence to the key point is high enough, then the sentence is covered by the key point, supports the key point. So yeah, it's a sense, it's similar to clustering in one sense, but the ability to understand what's the center, what the collects the sentences together, the key point itself, is it's a very strong ability. Someone asked, how do we extract key points on our own data? You use our service, upload your data to our service, and run key point analysis. Maybe you meant on a sensitive data that can be shared. Was that what you've meant? If so, yes. If so, we can also supply our services as Docker images, where you can run them on your own Kubernetes or cluster or whatever, in domain, in-house cloud. So yeah, that's also possible. Please send us an email, and we'll be happy to assist and make it work. Which other languages? I guess you mean like, yeah, languages, not programming languages. So currently it only supports English, but say you have data in Portuguese, you can use a translation, a translator into English, use key point analysis on the translated sentences, and then map them back to the Portuguese data. And first tests of this flow yielded good results. So that's a possibility. We should examine it. It should work if the translator is good enough and it keeps the semantics of the sentences. So yeah, we can do that as well. Okay, does anyone needs additional more time? If so, again, you can write for me personally in the chat. Language translator do I recommend? Obviously, IBM's translator, but well, any translator, you can, I guess, check comparisons online and decide yourself. But IBM also has a good language translator you can use. Okay, no one told me they need additional time for section number 4. So let's go over it together. In section number 4, we select only the sentences that refer to the traffic problem. How do we do that? We use the term wikifier over the sentences and get all the concepts in the sentences. There's a bit confusion between mentions and concepts. The mentions is what's in the sentence, and it mentions the concept from the Wikipedia. So we can say that mentions and concepts are interchangeable. We get all the concepts from the sentences. This is a dictionary between a sentence to its mentions, to its concepts. We then take all the mentions in the data, in the text. And then we want to find the mentions that are similar to the traffic concept. So here we pass the traffic concept, and we want to find all the concepts that are similar, that have a relatedness score above 0.5 with the traffic concept. So we get all the concepts that again have a score above 0.5. This is the method that runs the term relator between the traffic concept and all the mentions in the sentences, and we print them to the screen. So we started with the traffic concepts, and these are the concepts that are related to it: transportation planning, lane, traffic, conservation program, speed, gridlock, bus station, train, and so on. These are, we can see that these concepts are highly related to the traffic concept, right? And now we'll take all the sentences that has at least one of these concepts. So here we filter the sentences that has at least one of these, that has an intersection with these concepts, that has at least one of these concepts. We have 980 sentences like that. And again, we run the key point analysis service and print the result to the screen. The coverage is relatively high, 60%, and now we can find key points that relate to the traffic problem. Please address the traffic congestion. We need better mass transit. We need better planning, and so on. So not all key points are perfect, but we can find different details, different nuances related to the traffic problem. So, last chance to ask me questions in the chat. In conclusion, I see we have such. Is the term wikifier using wikipedia.org, or is it using some other generic wiki? Again, I'm not too familiar with the implementation of the term wikifier. Full and correct answers are in the project debater early access program site. Yeah, so I'll need to refer you to there. The key point analysis algorithm good for long text data like emails, chatbots, tech. So too long data might be problematic, but when we break it up to sentences, it can work well. Obviously, when splitting to text to sentences, some detail might be lost when we break the context, right? Some things can be can have the context missing, but yeah, it should work also on longer text when we split it into sentences. So in conclusion, I really hope you've enjoyed and found the tutorial interesting. I hope that you come and use our services in your own use cases. And I hope you've seen that combining several services can create a strong text analytical tool. So thank you very much. Someone asked if project debater, I guess he meant these services, run on GPUs. So yeah, the models run on many GPUs. And some computations here are relatively heavy. Therefore, the key point analysis service on bigger data takes longer to run. Okay, so thank you very much.
Great, thanks, Yo, for the workshops and tutorials. We have a few more minutes. If anybody have last-minute questions, feel free to post in the chat. Or if you want to speak to ask questions or even make comments, you can raise your hand. Actually, you can unmute yourself to speak.
I'll be happy to hear someone accept me, other than me.
Hi, a quick question. So are you able to, just like you're able to translate from one language to another using a translator and map back, can you do the same thing for voice to text?
Yes, sure. If the speech to text is good enough and it captures the semantics well, then I don't see a reason after when you have the text to analyze it using the key point analysis.
Okay, so everything is based on the semantics. The semantics is key. So if you're dealing with, for example, a bad translator or a person who's not speaking fluently the native language, then you have to overcome these obstacles.
Yeah, as usual, when the data is more messy, then the results deteriorate. And yes, as long as the semantics is kept, I expect the service to keep on working well. Someone asked if when the services are provided as Docker images, does it still run on GPUs? We give you the Docker images and you run it on your own environment. So you will need to run them on GPUs. Yeah, it will need to run on GPUs, but it will, if we supply the images, you'll need to have the nodes, the instances that have GPUs.
Great. Anybody else? Questions? Comments?
So another quick question. In case you had text embedded in images, in such a case, again, it's a question of semantics. If you had a pretty good OCR or reading, then again, it's pretty similar to the other two cases that you have, I would assume.
Yes, so keep in mind what key point analysis is doing. It finds the key points that are repeated in the data, right? You have the number of sentences that match the key points. So you need data that is similar in this aspect, right? Data that has a lot of data that you can't read yourself, but it has a repetition in it. And you want to find to cluster it semantically around key points. So if the data is in that sort, it doesn't matter if it comes from images or translated or speech to text, as long as the quality, the input quality is high enough, and it's data that has repetition in it, then this summarization could work. Someone asked about NVIDIA containers. I'm not familiar with this specifically, so I'm not sure how to respond.
Yeah, so if for Dave, I think you posted the information for the NVIDIA's. Maybe you can like post some like document or link, so other people can check it out if they're interested.
Someone asked if it works for speech recognition. What do you mean by speech recognition? Speech to text?
I think the question from the Sanket, I mean, if you want to, you can, just speak to explain the questions.
Identifying words
I'm
in a
also not
speech.
sure about the questions.
I don't see how it doesn't identify words in a speech. No, it summarizes data, but no, I don't see how it can identify words in a speech. Someone asks, how do we know if the data of high quality is bothering? How do we quantify this equality or maybe quality? Well, obviously, data quality is not well defined, right? Also, human labelers or humans that read the sentence and need to match sentence according to their similarity requires some sort of quality in order to be able to do this task. Similarly, the model obviously requires the input to be good. If we transform the data with a translator that can add mistakes to it, or speech to text that can add mistakes to it, the more mistakes we add, then the lower the ability for the model to perform. That's what I meant. But that's also similar for human labelers or such. So yeah, you don't need to hold some sort of high quality of the data, but when you put mistakes in your data, you can't expect a model to perform as well. So someone writes about the NVIDIA GPUs code that works in Docker containers. I'm not familiar with it. I will need to look into it. Maybe again, if you want to use our services and have specific questions, feel free to contact us in the email. Maybe I'll post it again. Our email for using our services, for asking additional questions, please send us an email and we'll be happy to respond. How to find positive or negative words in the context using this IBM key point analysis. So finding, we have a Procon service, which I didn't mention before, that receives a sentence and gives it a Procon score, meaning if it's positive or negative. So that can be used for in the sentence level, not in the words level. And another thing that can be done, not sure it's related to the question directly, instead of running key point analysis on the entire data, you can first split your data into positive and negative sentences. Say in a survey, you can split it into positive and negative sentences and run key point analysis separately on the positive sentences, finding positive key points, and on the negative sentences, finding negative key points. So that's also something we've done, and it yields very nice results. But finding negative words, I don't see something we can do in the words level. So someone said, I'm concerned about text that mention the same subject matter, but in different ways, not exactly the same words, for example. So that's exactly the difference when you detect semantic similarity and not syntactic similarity. We use behind the scene, there is a Roberta model. The Roberta is a language model that was trained on a huge data set, not by us, by the ones that released Roberta. And after being trained on that large amount of data, it gains some sort of language understanding to some extent. And we use that model, that language model, and fine-tune it to our specific needs. So in this case, we fine-tuned it to detect when a sentence matches a key point. So the model we use, the Roberta model already has some language understanding. So it can detect semantic. It does have some semantic understanding. It knows when you say a bank, if you mean the bank where you put your money or the river bank. It looks at the entire sentence and is able to understand these conflicts. And on the other hand, it does understand when you say the same thing with different words. As we've seen before, we've seen that the key point talked about the traffic problem in Austin, but the sentence said that there is a problem with the north-south arteries. It doesn't say nothing. It doesn't say traffic or something like that, but north-south arteries is related to the traffic problem without any similar words between the sentences. So the model does have some semantic understanding, again, to some extent.